Good afternoon, I'm Mr. Ish. Thank you for joining me. We're looking here at a single titration question, a weak base and a strong acid titration question. We have a weak base which is 250 milliliters of 0.1 molar. We're not even worrying about what the identity of this weak base is. 250 milliliters, 0.1 molar, it is titrated with 0.25 molar HCl, which is your strong acid. We have to find the pH at equivalence point. The base dissociation constant for that weak base is 3.2 times 10 to the minus 5. What's the manner by which we will solve this? Your clue is right here. At equivalence point, your moles base will equal to your moles acid. We don't know what the moles acid is, but we can easily determine from the moles base. We have 250 milliliters of 0.1 molar. And the milliliters always have to be converted into liters. We have 0.1 molar times 0.25 liters. It should equal to your acid items, which is 0.25 molars times x liters. What is x? You're going to do 0.1 times 0.25 divided by 0.25, we're getting 0.1. But what is this 0.1? It's telling you it's 100 milliliters. At equivalence point, we're going to be using 100 ml of HCl. We don't need to see this anymore because we've already utilized and we've obtained our information, which was this. What is our reaction that we're worrying about? It's this. You have your weak base, we'll call that BH. It's being hit by HCl. And what are you going to have over here? You'll have your conjugate acid, BH2 plus, and your conjugate base. You have start, change, and end. Well, what are we going to put over here? We'll put our moles. 0.25 times 0.1 is 0.025. I have 0.1, which is 100 milliliters HCl, 0.1 liters times 0.25. Again, it's 0.025. We have 0 over here. This will decrease by 0.025. This will decrease by the same amount. This will increase by 0.025. When you do this, you're getting 0.025 here, but these are zeroing out. Why are they zeroing out? Because at equivalence point, moles base, your weak base, is equal to moles, your strong acid. This is the only thing which remains. But what do you do with this? Your reaction will flip. The reaction will flip around because at equivalence point you have the reverse reaction come in, and then you have to start worrying about your acid dissociation constant because now your conjugate acid is driving everything. How are you going to determine your Ka? It will be Kw divided by Kb. We have Kb. We have Kw 1 exponent 14 minus divided by your base dissociation constant 3.2 exponent 5 minus. I have 3.125 times 10 to the minus 10. Your K is equal to 3.125 times 10 to the minus 10. We'll save this because we'll need it. The reverse reaction. And then you have BH plus HCl, your weak base and your acid. Here you have a start, change, and end. What are you going to put over here? Now you want to put molarity figure here. I have moles. You know molarity is equal to moles over volume. If I were to divide this by my volume figure, I'll get my molarity. What is my volume figure? Well, we have 100 milliliters at equivalence point, and we have 250 milliliters. We have 350 milliliters, which is 0.35. 0.025 moles at equivalence point divided by 0.35 liters. So you'll take this 0.025, which is your moles of this conjugate acid, divided by the total volume of the system, 100 plus 250, which is 0.35 liters. You have 0.0714286 molar of this conjugate acid, 0.0714286. You have 0 of this, as you see. You're going to decrease this by x, you'll increase this by x plus x, these will be x, this will be x, this will be 0.0714286 minus x. Now, since you're dealing here with a conjugate acid, you'll do your acid dissociation. You can have this, these two, x times x, which is x squared, divided by this, 0.0714286 minus x is equal to your Ka, which is 3.125 times 10 to the minus 10. You could technically just eliminate that x and simplify it. You don't need to keep it. You don't need to keep it because this acid dissociation value is kind of small, very small. You'll do 3.125 exponent 10 minus times 0.0714286. You'll square root it. When we square root it, we're getting 4.2455. What does this x value here indicate? Your x value here can indicate the concentration of your HCl, which you can say is synonymous with H+. That's what it's indicated of. and you can just say that is equal to 4.7245 times 10 to the minus 6. This represents my hydrogen ion concentration. You know pH is equal to negative log H plus. You just have to send that value through that pH formula. I have the value over here. I'm going to do the log and I'm going to do minus. I have 5.325. What's the pH at equivalence point? It's 5.3256, and I'll put it for you right here. 5.3256. That's the pH of this. You started out with a weak base which would have had a relatively basic pH, and then slowly by the addition of acid you've brought the pH down closer to the more acid range. At the equivalence point you see pH is a little bit more acidic. Moles base, moles acid are equal to each other. You have the conjugate acid dominating the system, hence the pH is in the more acidic range, and that right there would be your answer, which brings us to the end of this video. Thank you.